couple problems involving multiplication and division of rational expressions. I'm going to start out here with a multiplication problem. X squared plus 6x plus 9 divided by x squared minus 4, and then times x minus 2 over x plus 3. Now, in multiplying fractions together, you multiply their numerators and you multiply their denominators. So I'm going to go ahead and do that. And while I'm doing that, I'm going to go ahead and factor everything that I can factor. The first fraction, I can factor the x squared plus 6x plus 9. So that would be x plus 3 times x plus 3, or x plus 3 squared if you like. And then in the denominator, the x squared minus 4 factors into x plus 2 times x minus 2. And multiplying then by x minus 2, which I can't factor any further, over x plus 3. Now, when multiplying the two fractions together, like I said, I'm going to multiply the numerator of the first one times the numerator of the second one, and then the denominator of the first one times the denominator of the second one. Both numerator and denominator at this point are completely factored, and I can cancel like factors. The x plus 3 is a common factor between both numerator and denominator, and also the x minus 2. So that'll leave me with an x plus 3 over x plus 2 as my final answer. Now another example, a division problem. Let's say we have x plus 1 over x squared minus 1 divided by x plus 1 over x squared minus 2x plus 1. In division, the thing to remember there in dividing two fractions is you take the first fraction and multiply it by the reciprocal of the second fraction. So my next step is to do that, to turn it into a multiplication problem. And while I'm doing that, I'm going to go ahead and factor everything that I can factor here. So in the first fraction, the denominator, x squared minus 1, will factor into x minus 1 times x plus 1. And then when I change it to multiplication, the x squared minus 2x plus 1 in the denominator is now going to be in the numerator. And I'm going to factor that. That will be x minus 1 times x minus 1, or x minus 1 squared. And then the x plus 1 in the numerator of the second fraction is now in the denominator. So going ahead and multiplying the numerator of the first fraction by the numerator of the second fraction, and then the denominator of the first fraction times the denominator of the second fraction there. And then looking and seeing that I have the numerator and denominator completely factored, I have some common factors. And now I'm left with x minus 1 over x plus 1 as my final answer.